I'm Douglas Fallstrom. I run products here at Hammerspace. So we're going to talk about the global active Geo-Spanning namespace. I cannot put more words before that. We tried, and it didn't fit. So no, I'm just kidding. And this is going to be, this isn't working. We have 14 more minutes, so we're going to do a quick run on how it works. And I think you guys got in the core of the product. We'll show you a quick demo, and then we'll wrap it up and tie it back to Mike, Tiffany, and Frank that we spoke about. It feels like 2 hours ago at this point. So as part of building a namespace and the metadata services and the data services that we build, we want to make sure that we adapt to the hybrid cloud, which is where the geo-spanning aspects come from. Customers don't want their data stuck necessarily even in the local silo, but even in the remote silo. And you want to be able to leverage all these cloud services we kept harping on about that adds value to information about the data. We built a global namespace, but inherently storage independent. We don't sell storage. We're not storage. We simply help manage and consume the data that sits on storage. So it means that we can sit on top of NetApp, on Isilon, other third parties, eventually Windows file servers and so forth, and bring all that together in a unified namespace. That means we can take a subset of an existing volume, tie it together with other volumes, and build another namespace from it. It's a lot of flexibility built into the platform to help the customer achieve the ultimate goal of help managing the data, especially in a hybrid world. The storage independent, we built a system that is shared granular from metadata, and we spoke about this earlier. The metadata can be relatively rapidly replicated to any other destination that needs it, whether they're within even the same data center but different zones, or within the same company, or even into the cloud. Because the metadata is a relatively small amount of data in most scenarios, and it's file granular for data. So data stays in place until it needs to be instantiated somewhere else. And it's keeping the system, it sounds really simple, it's a bit complicated behind the scenes, but that's the experience you get from a user perspective. In demo that I've set up, and I'll show you the setup, I do nothing particularly secret behind the scenes. I just create a share, I'll link it to another destination, and then I just access the data. I don't do anything special with it. The system figures out that the fact that this site is accessing data, I need to have another instance over on this site, is doing it read-write, so this instance can be forgotten because it's no longer needed, unless it's part of a snapshot, for example. The benefit of a system like this is that we can also continue to run workloads at the same local file performance like you would have before. You have no penalty for turning on replication to another site. The system that's handled behind the scenes. And so it's not likely we're not solving the speed of light, not anytime soon. Maybe that's the next one. But the fact is that you can now run you continue to run your systems even against your existing infrastructure, and then you can expand that to the other destination. So with that in mind, here's the architectural view of things. Probably it's not visible online, but at least for the folks in the room, existing storage. With Sidak, I think a sidecar is a great terminology for how we can get started in the environment. To go in, you spin up a VM. It takes less than an hour to install and do the basic configuration of things like host names and passwords and what have you. You point it to the source of the information you want somewhere else, and that's it. We take care of everything else behind the scenes. We separate the data from the metadata. The services are things like the global dedupe we mentioned earlier, the ability of even serving the data, helping customers consume it through the view of the metadata we just spent an hour and a half talking about. Everything, because when we move things into object, like the hashes, it's already van optimized, deduped, compressed. So the data going in there is minimal. When we access on the other side, it gets re-inflated into whatever form it came from, right? So whether you're sitting on NAS on the other side or even an object. This is bidirectional. So in the demo I'll show you, I'm doing this follow the sun demo, the data flows and the metadata comes along with it. Right? So it's bidirectional. Initially, when you sit as a sidecar, it's a one-way conversation. We spoke about how that will eventually become either bidirectional, or the customer will just start using it directly through the views of this. We'll see how that goes. It's always fun doing live demos, and I decided to not do a live demo today, even though I'm usually the proponent for it.
One live demo was enough.
Very simple, and this is what happened. I literally recorded it this morning. It's nothing particularly exciting. Creates a share, goes pretty quickly. I'll spit up a few operations that takes longer. Like for example, it takes 30 seconds to create a replication point that happens in 3 seconds in the demo. I don't think it makes a big difference. This is the key part here. In order now you have a share, whether that's assimilated, like David showed earlier, you can do it on the command line too. Or if you want to do a brand new share like I did, and in the demo I create a file, all you do is you create a replication source, you point it to the destination that's running Hammerspace on the other side. That can be inside a VM, it can be inside a bare metal server, running as an AMI instance inside Amazon. It's an IP connection to the other side. It's secure encrypted. My passwords are admin, if anybody that wants to know, probably doesn't matter. The interval is interesting. The way the product works right now is the desired interval, 5 seconds for the replication checkpoints. Okay? I may not be able to meet that based on my latency, and that's okay. We attempt to take 5 seconds after the last time it's finished. So we try to do it as best as we can. And that can be different and configurable throughout the system, so you don't have to do the same thing everywhere. You might have a share that you say, I just want to synchronize it once a day. And that's okay. You don't have to have the same behavior. And this is just for the metadata. The data itself is flowed and managed differently. That's the power of the system. So again, this takes about 30 seconds to do. I'll speak really quickly. As you can see now from a share listing perspective, you now see there's at least one more participant of this share. And David didn't mention it, so I get the chance to do it this time. Our shares become self-managed. That means that if I wanted this share to move from one Hammerspace instance to another, all I do is link them together, let the metadata synchronize, I delete the share and the source, and I'm done. I'm not moved from one data center to another.
Well, you should probably let the data align first so that it's
let the data align.
Yeah.
Obvious reasons, but that's how simple it is. It's not a complicated 6-month project. There's literally 2-3 commands and a bunch of logic behind the scenes.
In other words, the namespace actually exists transcendent of even Hammerspace. You can have one Hammerspace handed off to another on another site, turn off the original one. So participants can come and go. The namespace is something that even has its own identity and can authenticate against and so forth.
Almost like a pub sub message bus.
Well, it's an envelope. It's your file data in a Hammerspace, a separate existence that's not coupled to anything in the infrastructure.
Who can implement this? I mean, this is just you say it's self-service. So can an end user just? They're not going to run a command like this, right?
No,
but so
not this particular one, no.
Yeah. So
So we started with API CLI, by the way. The nice fluffy UI will come, and that will be how the end user will.
So while infrastructure isn't really you're going to target the data consumer and those folks. That's where your target market is. You still need the infrastructure component to go build.
So you need a Hammerspace services running on each side, and then he can create namespaces, work with metadata, share those namespaces across to other sites that are running Hammerspace. So he's viewing the world from, I have an envelope, a file system with rich metadata and access, and I need that present on different sites. And then I need the data distributed thusly across those different sites.
Are you planning on covering the commercial proposition as well?
Pardon?
Are you planning on covering the commercial side as well of the solution, or is it just pure technical?
You mean the go-to-market or the go-to-market and cost side?
Yeah, the pricing.
We weren't planning to, but we can address that towards the end.
Yeah. I think we have. Do we have Q&A time, or is
We have. We have 5 minutes.
Okay.
I'm glad I did a quick demo. So we create in this case. So just a few comments here. We start with 4 nodes. That's how we go out the gate. The technology can build much bigger envelopes of Hammerspaces. We don't think you need to go beyond probably 8 or 16 somewhere because it's more unrealistic. Someone's going to sit with the same share in so many different sites. What this demo does is pretty straightforward. Opens a file. Each site has a different color. Opens a file, adds data to it, does an MD5 checksum, renames the file, so make sure we have metadata transactions. On the next site, make sure that the contents matches the source or the file name, and it continues going on. And I let this run until I get bored.
Is it appending to the same file?
It keeps appending to the same file.
So it's the hardest case where it's not just different files in different directories. It's the same file getting edited at one site and then shifting and getting edited at the next site.
So imagine an M&E workshop where, obviously it's not going to move every 5 seconds or every 90 seconds. But it might move once or twice a day. You start doing in LA, then you move to maybe the East Coast or vice versa, and then you move to Asia for production and so forth. This allows you to do this follow the sun. It's a very simple example. Possibly the next one we'll do, which the product order is capable of. You can do read and write to both sides at the same time, not recommend the same data because you're going to get a lot of ping-ponging, but the same share, the same directories, there's no share locks, anything like that, and it will automatically merge and synchronize. Right? just looks really complicated on the screen, so I decided to do the quietly simple ones.
If I can jump in, another real important point is all of this works even with the ability to do snapshots of the namespace. So you can have the namespace being snapshotted across time and getting replicated and distributed across space where it's being edited from those different places.
So
On snapshotting the file system, what's the impact on my data in that particular case? How do I differentiate
I'm gonna,
a file object?
yeah,
that
so
is
let me pause on
snapshotted?
that because I want to make sure I cover this part
Okay.
first, and then we'll get to, because we might run out of time. I will give you an answer though, but we might run out of time. This is what I just demonstrated. 4 sites, storage independent, size independent, guys. So you can have a terabyte volume on size 1, but your data is 100K. Have 200K on the second site. It doesn't matter. Change them over time. I'm keeping it very simple. All synchronized together. So you link them together. The metadata doesn't bounce from one to the other. It simply goes from point to point. And in this particular config, I had a shared S3 bucket that ended up being my data dispute, my global dedupe source. Doesn't mean you need to do it in real life. In real life, you might have an object bucket on each site that ends up keeping multiple copies of the data because it's cheaper than versus bouncing from site to site.
And
completely choice, but
And because the data is dehydrated, hashed, deduped, it's only transferring the unique chunks between sites.
All right, so we already did that demo.
So it's globally WAN optimized, just like it's globally deduped.
So
With the assumption that you have an S3 type bucket somewhere in your data chain.
S3
Yeah.
or blob or
Yeah.
native object.
Yeah, something that will do that dehydration.
No, we do the dehydration. It's simply how we address the container.
Okay.
That's where
And
we
right
store
now,
the
we address
object.
object container like that today. yeah.
Okay.
All right, so quickly on the data consumers, we spoke about Mike earlier. He's now able to pick any cloud he wants. In fact, what he wants to do is copy the data from on-prem, putting in all 3 different clouds, and then his production people makes a decision that day where they want to render the system. They don't go and figure out what Mike made a decision on 2-3 weeks ago and what the cost might have been when he copied the data up there. Right? And it's on demand. And most importantly, we don't have to transfer all the data everywhere. So you move your workload up there, you run your HPC, your job on it, leave all the source in place, maybe archive it into Glacier if it's Amazon, and move only the results back on-prem if that's what you want, or even into another cloud. So it's very flexible. It keeps the cost low. From a marketing perspective, good point on the CLI. I don't expect anybody in the world to not have an IT degree and run that CLI. But she's going to be able to get a really simple experience where you just simply pick the source of data, is able to, through the collections and then automation, transfer that into their data lakes or what they might want to do with it. The edge site data transfer is really exciting to us because now we're able to sit out on multiple sites, and when they want to move the data into the source to do their compute to figure out the seismic data that has now been updated yesterday, now I want to run my native algorithms on the new seismic data, they can do that. Or they can also leverage the cloud for it. They're not stuck with just copying the data on-prem and then having to do something else to get it into the cloud. They can simply do both.
In this specific customer case, what's interesting is it's 2 different organizations. They are a consulting outsource for companies that own the oil fields and actually have the data. So this becomes a way for them to bridge across organizations, not just sites, in a way that replicates it, gives them the ability to pull the data on demand through the.
When you go grab all that metadata in kind of this, calling it this sidecar way, I mean, you're doing a scan on all of that data, right? And so the frequency
Metadata.
or the polling interval that you set.
It's very similar to how backup agents go and scan it, and benefits from the same thing, like the F policy interface that broadcasts what things in the namespace have changed, so you don't have to go scan it all.
Okay.
So the base implementation is revalidate the inodes with a single op to look up by file handle the C time, change time. So you have to probe every inode. And what's interesting, the folks who are in the backup business, like Rubrik or Cohesity, are doing the same kind of thing to capture the change sets that are going on within the namespace.
So what happens if I add a new site? So there is an initial replication or initial setup of the environment, right? So it's a bunch of virtual machines for the front end.
Doesn't matter when you add it or what the site is. So you could, the namespace transcends any of the Hammerspace installs. It could be running with none of the original ones, right? And you could hand it off to others. The namespace exists as an envelope of data and metadata that isn't constrained to the physical universe. That's where the name Hammerspace came from, by the way.
And if I have I don't know, a scale-out NAS, a large one, okay, and I want to adopt a Hammerspace, so I can't have my original data as is imported, can I?
You can.
We don't touch the data.
Well, you don't touch
can
the data, but
read it.
everything that comes after,
Yeah.
it's deduplicated and
Right.
sharded
So,
somehow.
yeah, right now it's one directional, so we would adapt to the changes that occur there and reflect it here. But changes that happen here wouldn't necessarily get reflected back until we do that bidirectional or gain enough customer confidence that they simply say, even for the on-prem, better to simply use Hammerspace as the namespace for that as well. So start with a sidecar model, maybe go to a bidirectional sidecar, or just go to a fully managing the data.
Still a question of what's my mount point? Is my mount point legacy NAS?
That's what it is, right.
Or is my mount point out of the Hammerspace?
And what we want is to
published?
not have to go in and ask people to change their mount point. And so replicating out and maybe even replicating back is called for so that they can leave their legacy infrastructure like it is and just grow with the new world of abstracting the two from each other.
So just to understand better, so on premises is the original mount point, on the cloud is the
We're
Hammerspace
rendering
mount point.
exactly.
Okay. And but if I change something on the cloud, it is not reflected.
It's not going to get reflected in unless or until we implement the bidirectional or they're willing to change the mount point on
But
the
you
local
can
side.
create another on-premises Hammerspace mount point.
You could, exactly.
And
so that's
at
the idea,
that
is they,
time,
they
it's,
can shift over when they want to use the new mount point.